show you the theory between the private CA and the MFA. So here we are just going to talk about the private CA as MFA. Okay, so sorry. So I would say is private CA as MFA. Okay, so this is the actual. So this video, it is all about the private CA and the MFA. And how it is actually supporting the IDP. Actually, IDP is not doing anything related to MFA, nor not in the application server also. As I mentioned on that last video, right, when I was demonstrating on the test SSO app and SSO app applications, in the front end only, that snippet is going to be there. So I have put up a JavaScript snippet. You can say it's a Angular TypeScript or whatever it is. So inside the snippet only the actual engineering is there to do the session killing and everything. Okay, so I will tell you. So if you could see, if you ask me, right, is there any dependency in this area of IDP? Actually, for MFA, no, it is not going to deal anything with respect to MFA, though it is getting actually integrated into the application server. And if you see the relationship of the multi-factor authentication, it is actually happening from the user device, actually from the happening between the user device and the private CA. Okay, if I say private CA, what I have done, I will tell you that is going to be a Ubuntu server, and I am running an API service, and that API service, it is in actually HTTPS as per the compliance, and that HTTPS, right, I have put the server certificate and the private key derived from the root CA of this private CA. Okay, I'm using a private CA. That private CA root CA will derive the server certificate of this HTTPS and of this HTTPS of this API. Okay, that API it will be on the internet, but that HTTPS of that API is signed by the root CA of the private CA and not the public CA. If I say public CA, right, and that is going to be a GoDaddy, VeriSign, DigiCert, or anything it can be. Okay, but in this case, there is a backend API set, right? That is actually a private CA's API. That's all. Okay, so what I have done, that I have taken that private CA API. Okay, I have created a JavaScript snippet. So what the JavaScript snippet will be there, it will do is, so that JavaScript snippet, it will wait for the actual application, for example testso app or sso app, right? It will wait for the GoDaddy's, let's assume the GoDaddy is a public CA. It will wait for the GoDaddy CA, right? All those, that verification process, the device and certificate, all those verification process to complete, and that the application should get the green lock, right? So the applications is here. This is the actual application where it is exactly, it is posted, and I am telling the green lock should come over here. Okay, so if you type it on the browser, right, in the user device, right, that green lock should come, and that comes from the application server link, which is test SSO app, or you can call it as SSO app, right, when that loads on the browser. So you get that green lock first. After, once that green lock is achieved as a step 1, step 2 is the JavaScript snippet is going to render. It is going to function. So what is there inside the JavaScript snippet is that wait until this green lock gets established completely, then this JavaScript snippet will run. So what it is actually having is that, right, it is having the private CA signed API, which is this. Okay, it is having one private CA API endpoint. So what that private CA API is having, it is having the private CA signed, private CA and then server certificate. server.crt and the respect dot key file. So that is what I can say is that this particular API over here is totally it is going to be self-signed in nature. You agree with me? It is private CA signed, right? It is self-signed. If you put that API directly on the browser, you will not get green lock. You will get a HTTPS will be scored out for that, since it is self-signed. So we are going to use that behavior as a MFA. Okay, how that is going to work? So if you put this private CA signed API on the browser, you're getting an HTTPS error as not secure, though it is actually HTTPS. If you get that error response, you are going to terminate the user session as blocked. If you get a proper response, then you will retain the session. Okay, so let's see here the two use cases of this private CA API's two responses here. Okay, so you will get a proper response and you will not get a proper response. So when you will get a proper response, when you have the root CA that you used to sign the private CA API certificates, that root CA has to be installed on the Android, iOS, or the Windows or the Linux machine. If that root CA is installed, you will get the proper response. If you have not installed the root CA, which is the negative use case, this API is going to throw an error message. So if you have yes and you have the certificate installed, you get a proper response. And if you have not installed anything and you have not put the CA, that private CA API is going to throw an error. So if it is going to throw an error, you will block. If it is going to give a proper response, you're going to allow the session. Okay, so this is the key. Now let's go back over here. Let's go back to this section over here on the browser. So you put test sso app.jargontest.in. So you have got the green lock. So the JavaScript snippet renders. The JavaScript snippet will have a call to this private CA. Will have a call to this private CA signed API. So two cases. If you have installed the root CA on this device, if you have installed yes, then that session will remain. Point number two, you don't have that CA installed of that private CA APIs, the root CA that is used for signed. If you don't have this installed, this session will not retain. This browser will show blocked if it is root CA is not installed. If it is installed, it's not. So what happens is that if you have the root CA installed on the respective user device, okay, if you get the proper response, then your JavaScript snippet will allow the session to just retain. If the root CA is not installed and if you are going to communicate to that API is going to go throw error only because it is an exception. You don't have the CA because the private CA root CA is not there with you. You cannot expect self-signed API's response to be proper if you don't have the root CA installed on your machine, which is nothing but you're not going to get a green log. That throw error will come back. If that error comes back, you're going to redirect your application to a blocked.html or anything as you like. Now I think you got that idea. So the same idea applies to mobile devices for iOS. So it works for Windows, it works for Linux, it works for Mac, OS X, it works for iOS, and it works for Android also. Android, I can put up a video for it. In the next video, I will show you how the mobile device recording, right, having that root CA or not, that I will demonstrate that to you. I hope this idea is very clear And I will say this is correct for any healthcare segment or any critical data, right? Any important government sites, even bank, it should work properly, right? So the main thing is that don't confuse with the IDP. I never spoke about the IDP in this video. IDP is just going to authorize the bit. IDP is just going is just acting as a medium of authenticating the user credentials that you put on the application server on the IDP form. That's all. The MFA is actually taken care by this private CA API. Okay, so you create a root CA certificate, a private root CA self-signed CA certificate. Use the CA certificate to create the server certificate and the key. You host it on the separate server that is going to be as a private CA API server. Okay, and you take out that root CA, put it on the device wherever you need, Windows, Linux, Mac OS, iOS, or anywhere. Okay, so I have this is this JavaScript snippet, right? It is going to be very generic for all these Windows, Linux, Mac OS, and Android platforms. It is going to remain generic. You can change it, right? Today you have AI, you can translate that snippet engineering. So the whole engineering is there inside the JavaScript snippet. If you are going to receive a proper response rate in this session, if you're not going to get the proper, if you're improper, if you're not going to write response, then redirect to blocked. So that is what is engineered within the JavaScript. Okay, so if, since it is going to be JavaScript, it is going to work in Windows, Linux, Mac OS, iOS, and Android. So it's Angular. I wrote it in Angular. You can write it in Next.js, React, HTML, Java, CSS, or you can just paste that JS as it is. Okay, so I think this makes a sound zero trust, right? The IDP you saw here, the and the integration sections and all these things, plus this behavior, which is acting as an MFA, that makes the concept related, and this is a perfect zero trust architecture. And thank you for watching this video.